Guys, welcome back to the channel. Today in this video we will cover our next topic, that is probability. So when you hear the word probability, what comes to your mind? So it may be gambling, winning a lottery, rolling dice, or predicting elections, stock market, or the flight delays. But here is the truth. Our entire world runs on uncertainty. We constantly ask the questions like, will my flight be late? Will this product fail? Or will this model predict correctly? And the tool we use to measure uncertainty is called probability. So in this video, we will cover what probability is, difference between probability and likelihood, what is difference between probability and statistics, joint and union probability, conditional probability, Bayes theorem, binomial distribution, and the beta distribution. So let's start the video. So what is probability? Probability is how strongly we believe an event will happen. How strongly we believe an event will happen. So it answers the questions like, what are the chances of getting 7 heads in 10 coin flips? What is the probability of winning an election? So most of times we express the probability as a percentage. Okay. So like we say, there are 70% of chances my flight will late. But in mathematics, we usually write it as in decimal. We use 0 and 1 for that. Okay. So for example, if I am given 70%, so I will write like 0.70. Similarly, if I'm having 100%, I will write 1.0 as my answer. Okay. And in machine learning, whenever we are writing a percentage, writing or describing a probability, we usually write in this notation. Probability of x is 0.70. So x basically defines an event. Like, what is the probability of getting two heads, right? So this is the our event, and we consider it as an x. So what will be probability of not happening? Okay, what is probability of not happening? So if an event has a probability of 0.70, then the probability of not happening is 1 minus the its probability. Okay, so we just write p of not that event and we represent it as 1 minus 0.70 and it gives us 0.30. Important note that we need to remember is all the probability outcomes must add up to 1. Possible outcomes and this is valid for only probability, not for the likelihood. Okay, so let's talk about what is the difference between the probability and the likelihood. So here we have the two terms. First is probability and second is likelihood. Okay, so probability basically means very often we have seen people are using these two terms as the same and consider these two as the same, but there is a difference. In probability, we are predicting the future, we are predicting the future, but in likelihood, we are measuring the past data. In machine learning, we use likelihood to estimate the probability. We learn from the previous data so that we are able to make the prediction. So we can say we use likelihood to estimate our probability. Okay, so what is the now let's discuss the probability versus stats. Statistics. So probability is basically a theoretical term. It does not need any data. Okay, so it is a theoretical term. It does not need any data. But statistics needs data. It requires data. So probability is just like a fair dice has six sides. So probability of 4 is 1 by 6. Okay, we have a dice, 6 faced dice. And if we want to calculate probability of 4, probability of getting 4, it will be 1 by 6. Okay. So this is just probability. But if we're talking about stats, so it says roll the dice many times and collect the data and then estimate the probability. So stats is basically used if a dice is biased or not biased, or if we're getting the answer properly. So we use the statistics to measure the biasness of a dice. So here we basically collect data to check the biasness. Then there is another term that is a joint probability. Basically means when two events A and B happens together. For example, we are having an example. We flip a coin and roll a dice. So we need to find the probability of what is probability of when of getting a head and a 6 on dice. So we know probability of getting head, let's take A, will be 1 by 2, and the probability of getting 6 on dice 1 by 6. So as it is joint probability, we have to consider these two events together. So we write probability of heads and probability of getting 6. Or we can also write P of A and B. That is equals to 1 by 2 into multiplied by 1 by 6. We're getting 1 by 12. That is approximately equals to 0.083. And this is called the product rule. We are assuming that these two events are independent. Therefore, we're just taking the probability of A into probability of B. Okay. Then we have union probability. So in this case, we take OR, mutual exclusive events. We consider mutual exclusive events. For example, rolling a dice, rolling a 4 or 6 on dice. Here, these two events cannot happen together. Two events cannot happen together. So probability of 4 or probability of 6 will be 1 by 6 plus 1 by 6, and we got 1 by 3. So okay, here this is a case 1, that is basically mutual exclusive event. Exclusive events. And there is another case 2, when non-mutually exclusive events. So here, if we take example of heads or rolling a dice, rolling a 6, then in this case, we cannot just add 1 by 2 plus 1 by 6. That gives us 0.66. We double count the heads and 6. In this case, we have taken heads and 6 together term also. So in this case, we use the sum rule. So in sum rule, we are just we are having probability of A or probability of B, and that is equal to probability of A plus probability of B, and subtracting the common probability of A and probability of B. So by using this math formula, 1 by 6, we got 0.53833. Then we have conditional probability. So in this, we have some condition given, and on the basis of that, we calculate the probability. So we define probability of of A given B. So we define as probability of event A when given event B happen. Okay, so the notation is like A when B happens. Okay, so the example is 85% of patient drank coffee. That does not mean 85 coffee drink can get cancer. So it help in decision making on the basis of some conditions given. Then we have Bayes theorem. Theorem. Bayes' theorem help us in flip conditional probability. So it says probability of A given B equals to probability of B given A into probability of A divided by probability of B. So if we take an example in which we are given the probability of coffee, that is 0.65, probability of people who has cancer, that is 0.05, and probability of coffee with respect to cancer will be 0.85. Then we need to find the probability of cancer when people who drank coffee will be 0.85 into 0.005 divided by 0.65, and we got 0.65%. Then we have binomial distribution. It is used when we have fixed number of trials, of trials, and we have two outcomes, success and failure. For example, we have like 10 engine tests. Out of 10, 8 success and 2 fail. So it helps us to solve the questions like if true success rate is 90%, how likely is 8 by 10? Then we have the beta distribution. So in beta distribution, it's talk about the probability of probability. Probability of the probability. For example, we are given 8 success and 2 failure. So we are having results like probability of success so probability of success greater than equals to 90% will be 22.5%. Or if we want to calculate success less than 90% will be 77.5%. So this is all about today's lecture. Let's take a quick review. So firstly, we learn about the probability. So probability is how strongly are the chances for that particular event to happen. And we usually calculate probability in percentage, but in mathematics, we write in between 0 and 1. We use decimal instead of percentage. And then we talk about probability of not happening an event. So it's just like not the probability, not occurring of that event. So we basically subtract probability of an event from 1, and we get the probability of not happening that event. And the important point that we need to remember is like all the probability outcomes must add up to 1. Then we learn about the difference between probability and likelihood. So probability basically predicts the future, but likelihood measures the past data. And in machine learning, we basically use likelihood to predict the probability. Then we see the difference between probability and the stats. So in probability, it's just a theoretical term. We calculate once, but in statistic, we calculate probability multiple times and we collect the data. And on the basis of that, we take some decision and check that that particular object or particular thing is biased or not. Then we covered the joint probability. In this, two events occur together, and and it is basically we multiply both events probability if these two events are independent of each other, and these is basically known the product rule. Then we talk about the union probability. In this, we basically take or, and here we have the two types. First is mutually exclusive events. We basically check for two events, and these two events cannot happen together. So in this example, we see the probability of 4 or probability of 6, and we have added both probability to get the final answer. Then we have non-mutual exclusive events, heads or rolling 6. So here we can't use the same formula that we used previous. In this, we use a rule base and which says that to calculate for probability of A or B, we have to take probability of A plus probability of B, and we have to subtract the common probability. So we minus probability of A and B, and then we got the answer. Then we have the conditional probability. It is basically we are given some condition, and on that condition we apply or find a probability. So we say probability of event A given probability of event B, or the event B happens. So this is the notation how we define, how we write the probability of A with respect to B. Then we talk about the Bayes theorem. So it is basically a flip of the conditional probability. Then we have binomial distribution. So for binomial distribution, there are two conditions that need to be satisfied. So first one is there must be the fixed number of trials, and second is there will be only two outcomes that represent success and failure of the outcomes. Then we have the beta distribution. So it basically measures the probability of probability. Like in this example, it is checking success that is greater than 90%. So in we can take another example also. For example, if we consider class of 30 and if we see how many students get passed in exam, so there can be the many students, but if we check how many students got marks more than 90 and they also passed the exam, so in these scenarios we can use the beta distribution. So this is all about today's lecture. Thank you. Bye bye.